it's very compact and it's very reliable, and also high performance, but it's very expensive. And here's the detail of the configuration of our AutoCAD terminals. So I may just skip it. And here is specifically about the view modules part. And you see the commands came from the computers and to the AutoCAD, and then transferred to Kaihong to each individual element, and then drive the motor. And here's technical details about how we use the ELs. Use this part, and we can just skip it. And the last one is about our newly developed ROS-based software. Why choosing ROS? Because our answer is has great flexibility, and it was easy to use, and the modularity and the reusability of the code can be improved, and a lot of useful tools for debugging, like the dynamic reconfiguration, and like the RQ board and several other tools that is very useful. And it is also maybe a good chance for promoting the mixed team for the World Cup. And right now, the ROS community is trying to provide better support for the multi-robot system. And data logging. And here is the overview of our system structure. Here you see the green one is represent a node in the ROS system, and from our robots we can separate in 3 categories. One is about the driver. It acquires raw information about like image and like any other readings. This is the already existing node that came from the ROS community, and this NuBot hardware control is robot specific, and it was developed by ourselves, and this node is in charge for like the sensor reading, like the kicking command, and also the the motors command. It's like you know the let me say, and after extraction, this part is about how we process the information, how we process the image, and extract the information to make a raw model. You see, here is an RTBD node, but currently we are using the UDP communication that receive information like the coach command and message from the other node, message from the other robot. And here we process the image from the front camera and detects the balls, the distance about the robot. And this is for the localization. And then the world module node that gather all the information and provide a complete world module for the mobile, for the robot. After that, the NuBot control is in charge of decisions like where should I move, and when should I kick the device, when should I kick the ball, or should I start dribbling, and like so. So all this motion commander goes into this NuBot hardware control, and the robots then start moving and acting. So this is the system structure of our robot. And for about years, we have encountered several problems. One is the ROS is not optimized for real-time application, and we have to, because you have a lot of process and any other computation, you have to manage the process and do the schedule by yourself. And the next is also a big question about the versions form. We are currently using the Groovy, and but now the ROS has developed into the version Indigo, and the problem is some driver packages we are using are obsolete and not supported in the newer ROS version. So if I want to move to the newer ROS version, I have to do the maintenance and any other thing, and some software are not supported in the newer ROS version, so we are stuck to the older one. And also, when we encounter a problem, the solution is to ask the ROS answer, but we seldom have reply, so we have to do it by myself, on our own. And the last one is you encounter a lot of small bugs, and sometimes it's just quite tricky. And here's the thing I want to introduce to you is about the RT patch Linux kernel for Ubuntu. It was developed by our university, but the other groups. So it's about how to improve the real-time performance for Ubuntu. And here we have to do an experiment with the patch. This is about measuring the processing time in the kinetic mode with and without the RT kernel. The red one represents the normal one without using RT kernel. You can see the time jitter that is very severe, and sometimes makes quite tricky. And here's the blue one, means the improvement when using the RT kernels. You can see the difference. And also the other group of the university have developed the micro ROS RT, and it was modified ROS C++ kernel, which adopts OMG, DES, and a lot of stuff. So if you are interested in this, you can have a try. And thanks for your attention.
Can you go 4 or 5 slides back? More. Stop. Here. So great flexibility and use. All the rest you say after that contradicts this.
What?
Great flexibility and easy to use, but everything you say after that is all about it's not flexible, it's not easy to use. What remains still in your first line there?
This idea came from earlier when we start using the ROS. We think, wow, so amazing! We have this, and it was there.
The first thing is the promise.
Yeah. But when you go deeper, you're like, oh my God, there's a bug.
Yeah.
How to fix it? So.
But the real-time thing is this. What exactly is it?
What?
The real-time curve.